Okay, so I've started working my way through the exams. Um, I'm hoping that I started with those instead of homework too. So I think that I'll have most of them graded by Thursday. So I'll have like a little more information about what the average was and things like that. Don't panic too much as you're seeing kind of my comments or the grades come through. If they're, you know, if the average ends up being a little bit low, I might do like a slight curve to it. So hold off until Thursday. I should have all of the exams graded by then and have a little bit more information about kind of what those grades are looking like. And then I'll start in on kind of those second homeworks. As well as I've already kind of sent a decent number of emails out for project data, or I might have some questions. So the first time I went through the proposals, if it wasn't clear from your proposal, certain things, like I would get a general idea, but then they wouldn't one of you wouldn't mention like which league. So go back and make sure you check to see any of the comments that I left in those project proposals, because I might have needed a clarification question from a few of you. Okay, that's kind of where we're at. Any questions for me before we kind of dive into the next topics here today? Let's check the chat here. Okay. So the final exam will basically be starting from today to the end of the course, right? So it's not going to be comprehensive in the sense I won't be asking about specific topics, but we've learned things like how to set up a normal form game, how, think about the ticket market. We might be using some of that moving forward, right? So today, where we'll start, there we go. Whoop. All right, there we go. Is we're gonna start talking a lot more specifically about the labor market. So we've looked at this already in certain contexts, but we're really gonna dive deeper in some of the issues that are gonna arise. So we think about the labor market, right? We said it's kind of reverse of what we typically think about, because who's demanding labor, right? So we think about the major sports leagues. Who's demanding the labor? Well, those are going to be the leagues themselves, right? The owners or the teams. Okay. Now, there could be league-wide demand for players, but there's also going to be individual team demand for the players, right? Who's supplying the labor? Well, this is the players, right? So we said everything's kind of reverse, right? Because usually we think about kind of individuals being the consumers, and we think about like big companies being the producers. In this case, it's flipped. So what's the demand for labor going to be based on, right? So if we think about, the demand curve for labor, there's really a couple different demand curves, because, right, there's demand for a certain type of quality of player. There might be just overall demand to kind of fill rosters, right? We start to think, really, it's hard in this labor market to compare every single player, because every player is going to have a different quality, and part of how good that, or the quality of that player, how good they are, is going to influence that one player's demand curve. So we're going to be looking at it in a couple different dimensions, right? Maybe individual supply and demand curves, and then kind of overall labor supply and demand curves. So we can think about probably this quality. How many additional wins is that player going to bring to the team? How are we going to measure this? The number of additional wins. The team only cares if they're profit maximizing, because that's also going to generate additional revenue. Right? So which league, right, if this demand is based off of not just how many additional wins is a player bringing in, but what's the value of each one of those wins in terms of revenue to the team? Right? So what league might we expect to have kind of the lowest salaries of the four? Well, thinking about here, how much revenue, if we look at revenue per win, and we'll look at some of the data here, but if we kind of we had a discussion of it earlier in the course, where really the demand curves is kind of lowest for the NHL and probably highest for the NFL, just demand for the sport, right? So, I'm thinking about the amount of additional revenue a player could bring in. It's kind of handicapped by how much demand there is for the sport, right? It doesn't matter how, I could be like the best pickleball player in the world. It doesn't matter, right? I'm not going to be paid a couple $1 million because I'm not generating that amount of additional revenue. Okay? So probably we're thinking about the salaries of these different leagues is going to be pretty synonymous with just which sport has the highest overall demand. right? So we can look at ticket prices, we can look at attendance, we could look at kind of revenues of these across these different leagues. And we're probably thinking NHL is going to have the lowest, and I would expect, maybe NFL the highest, right? But that's, like I said, it's not completely synonymous. It's close to that idea. The thing about there might be an overall higher amount paid total in salaries, but for any one player, what also impacts is how many additional wins does that player bring in? And we kind of had this discussion already, which, well, for sports like the NBA, where you only have 5 players in the court at a time, you don't have as many people involved in the play of the game. Well, there, a superstar player can bring in a much higher number of additional wins, right? Than in a sport like the NFL, where there's, 22 people, just if you look at any one point in time on the field, right? And a lot more players used throughout the game, right? So we want to think about how can we construct this labor demand curve. What we'll typically do is think about teams have a choice between labor and capital. Like if you take other econ courses, you might even talked about, how do I, choose the different makeup or the different composition of these two things I have. Our discussion, we're going to assume that capital is fixed, right? And, it's not that wild for a sports example to think that capital is fixed. It'd be pretty reckless to assume that if we're thinking about maybe, I don't know, even something like how many Happy Meals that McDonald's is churning out, right? At some point, they could switch from having employees to having electronic kiosks that you order at. But you can't really put a robot out there necessarily to play the sport. So it's pretty safe assumption. We're thinking about capital as being fixed. And then how do I increase the number of wins I get? Well, it's changing the amount of labor I have, or choosing the optimal amount of labor, okay? So we'll start talking about, and I've referenced this term before, but we'll break it down as the marginal product of labor, okay? So the marginal product of labor is the additional, kind of in our context, the number of additional wins. Usually it's the number of additional output created, but for us, it's the number of additional wins, right? So we'll start calling kind of the marginal product of labor, the marginal number of wins from labor, right? Or the number of additional wins added from adding that additional unit of labor. Okay? So the change in wins from a change in the units of labor. So this is you can think about this as the number of additional wins a player is going to bring to the team. So we're going to be willing to pay, as a team, the player whatever the value is that they're adding to my team. Well, they're adding a certain number of wins, but what's the value of those wins? Well, that's just going to be the number of additional wins, marginal wins of that labor, multiplied by the additional revenue, or the marginal revenue from each additional win. So we've got these two components that make up the value of the marginal product of labor. Or actually, you could actually think of this as well, since we're kind of putting this in the context of wins, the value of the marginal wins that are coming from that labor, right? Or the value of the marginal product of labor. It's going to be how many additional wins they're bringing in, multiplied by the amount of additional revenue each one of those wins brings in. Okay? Those are going to be the two, components of our value of the marginal product of labor, which the teams would pay up to that amount. So they would offer a wage up to and equal to that amount. Okay? So, I didn't mean to switch off there. So we've got this kind of value of the marginal number, or value of the marginal wins coming from labor. However, we know that the marginal product of labor declines, or the marginal number of additional wins. I bring in the best player first, they add in 3 wins, and the next best player might add 2, and the next best 1, the next best a half, and so on and so forth. So because that's declining, we know the wage that these teams are willing to pay kind of the next quality player is also going to be declining. Okay? So the demand for labor curve is really just going to be whatever the value of the marginal product of labor is, or the value of the marginal number of additional wins that player brings in. So because we have diminishing marginal product of labor, we're going to see that we have a downward sloping demand curve, which is what we typically see. So if we kind of look across the sports, right, we're going to be thinking about these two components: the number of additional wins a player brings in, and kind of the marginal revenue per win in each league. So if we want to look a little bit more at the marginal revenue per win, we could look at kind of some of the revenue data, but here that should be reflected in the salaries, right? Because the wage that these teams are willing to pay will increase if they have a higher number of additional wins, higher revenue per win, sorry. So we look at NFL salaries. I just went back to the last 7 years and kind of graphed out. I think this excludes certain types of players. If I remember right, this was like only players that were on the field or were involved in the play. So you're not going to get some of the players that maybe are just there kind of to fill the roster and kind of for safety, right? To make sure you have backups, right? So it doesn't include those. So if you look at the average, it looks like it's hovering around 4 million. And even though demand has kind of risen, what we should see that same trend in salaries. Well, it does look like it's increasing a little bit, right? If I didn't have some of the newer years, I didn't have the average salaries for these leagues. So if we looked at the last couple of years, I was just roughly Google searching the data before I came to class, and it has kind of this upward trend. Okay? Major League Baseball salaries, pretty strong upward trend here, and we get the average is hovering around 4 million. But kind of the maximum salary we see in Major League Baseball, 31 million versus the maximum salaries we see in the NFL. Now this has changed over the last couple of years, since 2017, but there still exists that difference between the highest paid NFL salaries and the highest paid Major League Baseball. Right? Now, what could be the explanation to this? Well, potentially the number of additional wins each player in Major League Baseball brings in could be higher than that of kind of your top players in the NFL. And the averages are pretty similar, right? There's also some kind of certain salary cap issues that we have going on, differences between the MLB and NFL. But we'll kind of hold off on talking about those for a second. Well, for a second, probably not until Thursday, my guess. If we just get an idea about where's the NBA and NHL lie, we can kind of see here the maximum salary in the NBA is quite a bit larger than any in the league we have, and the average, I think I said the average there, the maximum salary, and the average salary is also quite a bit larger than any other league we look at. Okay? And this likely stems from the fact that any one player can have a much higher impact on a team or add a much higher number of additional wins because there's only 5 players in the court at a time, and the rosters are actually kind of smaller in the NBA than some of the other sports. NHL, kind of see there, they do end up having kind of the lowest maximum salaried player and also kind of the lowest average as well. Okay? So just looking at some of the differences to kind of set us up for this. So we've got this labor demand curve. And we're starting to think about how that's going to be influenced across the different leagues. But what about labor supply? So we can think about labor supply in a couple different ways. If we think about it on the individual level, right, then usually we think, okay, as wages increase, people are willing to supply more hours of labor. Okay? And we don't even have to break this down to hours. It's really kind of the units of labor. So maybe you could look at the quality units of labor that a person supplies. So it doesn't just necessarily have to be hours, right? Because I could put in the same 5 hours, but if I'm not trying, that's very different than me putting in 5 hours and putting in 100% effort. Right? So it doesn't just have to be that the person is going to supply more hours of labor at these higher wages, but potentially they're just supplying higher quality hours of labor. Okay? So, the athletes aren't necessarily choosing the hours of labor, right? But they're choosing maybe this harder to measure kind of quality of labor that they're going to supply. Now, you can also think about it not just at an individual level, you can also think on a broader scale, right? For the team, they have an overall kind of demand curve for labor. Each individual player could represent a unit of labor, right? The number of players could be our units of labor instead. So there's really kind of two different two different labor markets we could look at. One for the overall team, and then one for the individual player itself, right? So for the team, there we're thinking of a modern market where they're adding numbers of player as the units of labor, as opposed to kind of what wage one specific player is going to earn, well, there you're thinking about the labor supply as really a unit of labor, which is probably hours or kind of quality hours. Okay. So as wages rise, you know, like I said, we kind of default to thinking about people are willing to work more if they're going to be paid more, or try harder if they're going to be paid more. But there's a point at which there's kind of this substitution effect, which is as I put in, as I reach certain wages, right, there's going to be a point where I no longer really care, right? You could keep increasing my wage. I'm not going to continue to work harder. I'm either already, working as hard as I can, or you could think about it as, well, I've now got enough income to where money doesn't mean as much to me as hours of leisure, right? Now to work an additional hour, right? What's the cost to that? Well, it's what I'm not doing, right? So the opportunity cost would be how much I value the things that I'm not doing in order to put another hour of labor into this job. Okay? So at some point, we can think about that substitution effect is going to dominate, right? So this idea of kind of the opportunity cost, the price of leisure. And at some point, people might actually start working less, right? If you, instead of paying me $1 million, want to pay me 50, well, once I have that contract, I have that $50 million, like I'm not going to want to work near as much, right? I'm kind of set for life there. So there could be this point where we get to what we call a backward bending labor supply curve. And for most workers, we don't think of this as a real possibility. If I'm looking at the labor supply or the labor market, I'm thinking about labor supply for, say, concessions workers, if I'm talking about increasing their wage from $7 to 10 to 15 to 20, they're probably never going to stop putting in more hours of work, right? Because if you pay them 100, well, now I want to work as much as possible. I can earn way more. But for these athletes that we're looking at, we are starting to get to wages that are in the tens of millions. We may actually be hitting this kind of backward bending labor supply curve. And actually, increasing wages at a certain point, we may see that they put in fewer hours of labor or fewer quality hours of labor, right? They stop working as hard. I always say the example that I kind of think about this, and I'll draw this out for you here in a second. The person I always kind of think about lately, the best example is if you look at the UFC, you kind of think about Conor McGregor. So there was a point at which, his quality seemed to kind of improve. He always seemed to be working really hard. And the price per fight he was being paid just continually was increasing, right? At a certain point, when you get a certain amount of wealth, right, from these higher wages, I now look at that opportunity cost of, well, the dollar doesn't mean as much to me now as the utility that I get from, I don't know, spending time with my family or enjoying the money that I have. So it's something that we probably see play out a lot more when we're looking at these labor markets for sports, because the wages are just so high. Right? So, let me see if I can kind of get this here. So a couple of things we're going to be thinking about. Oh, I'm going to switch this over. Waiting for the dot cam to catch up with us here. There we go. So if I think this is I got one marker in here that's not, yeah, there we go. Starting to die on me. So I can think about kind of the quantity of labor here on my x-axis and wages up here on my y-axis. We said the demand curve for labor is going to be the value of the marginal product of labor, or that's the same thing, just kind of written in the context of wins, as the value of the marginal wins coming from labor, which is the marginal revenue per win times the value of that marginal win. Oh, I mixed, no, I didn't. Did I mix up one of these letters? There we go. We also have this supply curve for labor, which if we're thinking about an individual, right, we typically think about it as increasing, right? Kind of each additional unit of labor, or the easiest way to think about each additional hour, I'll supply the hour that I value the least first, then the next most valuable hour second, so on and so forth. And in order for me to kind of continue to supply more hours to you, you're going to have to pay me higher and higher amounts, right? If you want me to work the first 8 hours, maybe I'll do it for $10 an hour. But if you want me to work 12, you're going to need to pay me something higher, maybe like 15, or in the idea of pay me overtime, right? If you want those additional hours, I need a higher wage. As the wages increase, the labor supply increases as well, or the quantity of labor supply. But there might get a point where I'm content with however many hours of work this is, and however, whatever the value of the wage is there, I'm pretty content. If you offer me wages past that, well, I'll take the wage, but I'm going to work less because with that much money now, I value my hours of leisure more. So after this kind of point, we could see a backward bending labor supply curve. Okay? Which is kind of odd because, let's say this was the wage offered. The hours of labor, or the quality of labor hours that a team is going to get, is right here. But if they offer a higher wage thinking, oh yeah, we're going to get more from this player in terms of quality of hours supplied, you actually get a reduction, right? And I guess we can call this QL, we'll call this 2. And I'll call this, instead of using the prime, I'll go wage 2 up there. So, if wages get high enough, we could see this occur, okay? Any questions here? Now, I want to relate this to something we've already talked about that also kind of helps explain this phenomena a little bit. Okay? So, any questions on this before I keep moving, or okay if I take this off? Everyone got everything jotted down? Yeah. So think about this as the quantity of labor. So like I said, the easiest way to think about it is the hours of labor supplied, but it really gets a little bit trickier in that I'm limited to 24 hours a day, right? And in fact, if I factor in sleep and stuff like that, there's only a certain amount of hours I can supply. Right? And if you start to pay me more, in the context of sports, you don't really get to choose the hours that you supply, right? The games exist. You play in 82 games, I show up to practice, these are already scheduled. That amount is already set for me, right? But what I can do is I can work harder during those hours. So the most intuitive way to think about it is supplying more hours, right? And practicing more, focusing on my game more outside of practice and outside of the games. But it doesn't just have to be supplying more hours. It could be that I'm supplying more effort per hour, right? So there's multiple ways we could measure this x-axis, right? It gets a little bit tricky, but in terms of the examples we'll walk through, we're really just thinking about whatever that measure is, I'm supplying less of it here if I hit that backward bending part of the supply curve. Does that make sense? So another thing, when you think about with the fighter example, oops, I had the cap off that one for a reason. Throw it over there. So, we can also think about how now that we know what that demand curve is, we can start to think about the differences in wages we might see from different players. So for any one player, we'll call this the demand curve for player 1, right? And let's, for the sake of this example, make it easy. Assume that neither one of these players are going to hit, neither one of these fighters are going to hit their kind of backward bending part of the labor supply curve. And let's think about the value of the number of additional wins kind of brought from this player. So let's say we've got the marginal revenue per win times the marginal wins per labor from player one. Okay? So the equilibrium is going to be that this player earns this wage, and kind of this is the quantity of labor supply, right? Whether or not that's hours or kind of quality of hours. If player two has a higher marginal wins per labor, right? Or we can think about they're of higher quality. If having this player is going to add a higher number of additional wins to my team, then the marginal number of wins that that player is bringing in is greater than person one. Well, then if we think about the demand curve for that player, if they go to the same team in the same league, the marginal revenue per win is the same. However, we know that the marginal wins that second player adds is greater, so the demand curve will also be greater. Right? The value of the marginal wins per labor, that's just the demand curve. These are the wages that teams would be willing to pay for players of whatever quality that is, right? Bringing in that number of additional wins. Sorry, you might not be able to see my finger there when I was first pointing at it. You know, and what would that predict? Well, you know, that player is kind of intuitive, earns a higher wage, but also they're willing to kind of supply a higher number of units of labor as well there. Now, a higher number of hours or quality of hours there. Okay. So this is like the first way we can start to think about why do different players earn different salaries? Well, really it's because the amount that a team is willing to pay that player depends on the value, right, of what that player is bringing in. What does that player bring in? A certain number of additional wins. And if the number of additional wins they can bring in is higher, the demand curve for that labor or for that person will be higher, and they end up kind of, you know, willing to pay them a higher wage. Okay? Another way you could think about it is, and I'll use a blue marker here just to kind of show that this is a separate idea. Let's say that if you want to just think about the hours of labor supplied, let's say you calculate it and you say, well, none of these players have this many games, equates to this amount of time, this many practices, which equates to this amount of time. And so you say, look, if I do think about just the labor supply, like the number of hours that would be required for a season of play, I could figure out what that number of hours is. And let's say, okay, well, every player has to show up to practice, every player has to show up to the games. And so here is kind of how many hours of labor they're going to have to supply over the year. Well, for the lower quality player, for that many hours, notice the wage I'd be willing to pay is much lower than the wage I'd be willing to pay the higher quality player. Right? For that, so even if you want to think about it as the hours of labor supply, like just strictly count the number of hours, you can see here that, oh yeah, the wage that they'll pay that higher quality player is going to be higher than the low quality player. Any questions? I know I kind of overlaid the graphs there, so if you need any clarification. Okay. All right, so what did I have here? As per fight amount increases, number of fights increases at a decreasing rate. Oh, that was just the idea that you can kind of get this backward bending supply curve, which I already showed you. You know, you could also think about, I wasn't thinking about this. I showed you kind of demand shifts here. Thinking about difference in quality. I forgot the other thing I wanted to point out is, so let's say we've got the same fighter or the same player. So the demand for labor doesn't change at all. And let's say they don't even if they didn't hit kind of their backward bending labor supply curve. And I guess I probably should keep using this. So this is a supply curve for labor, but the first one, I'm going to make a shift here. So as I obtain more wealth, right, to get the same number of hours of work from me, you're going to have to pay me more money, right? In the sense that I don't, what's an easier way to think about it, right? So for these mega stars, like I'll use Conor McGregor again, right? If I already have over $100 million, sitting around in my bank account, you can't just offer me $500,000 to fight. You probably could at one point in time because my labor supply curve was down here. As I amass more wealth, to get that same fight for me, so here I could even think about the quantity of labor not being the number of hours, but here I could think about it as, for a fighter, the number of fights they're willing to participate in. Because unlike the other major sports, we're not fixed at this certain number of games, right? The fighters can decide to fight more frequently or less frequently. So to get that same one fight after kind of these fighters have amassed a lot of wealth, we would expect to see kind of this decrease in their labor supply curve, right? Because now they have this massive amount of wealth, the same wage before, maybe before to get that very first fight. So here, if you want to write in for this example, you could think of the quantity of labor here in this example as the quantity of fights, number of fights. So maybe before I could pay him this lower wage, well, after he amasses all this wealth, to get that same fight over the next year from that fighter, I identified the equilibrium. I didn't want to do that. To get that same one fight, I have to go up to that point on the new supply curve, which means now to get that same one fight in the next year, I'm going to have to pay that fighter a much higher amount. Okay? So shifts in this supply curve, right? What caused this was the additional wealth, right? This increase in wealth for the player or for the fighter. Okay? Any questions on that? So there I was just kind of trying to use two examples. One, we're thinking about kind of wealth changes. Here I was thinking about quality differences in the players, and we got an example of both kind of a supply shift, but also a demand shift in those labor markets. And we could identify the equilibrium points here, I think, pretty easily if we wanted to. I didn't do that here. I was more so trying to kind of explain kind of the differences in those supply curves. All right. So where's our labor market equilibrium? I kind of already identified on these graphs, and just like any other market, it's where supply is equal to demand. Okay? We're assuming we don't have any type of monopoly or monopsony power yet, right? So it's just where supply is equal to demand. So when demand increases for a league, so before I did it as though we had a higher quality player, and that caused the demand shift. We could also see demand shifts if there's an overall demand shift an overall shift in the demand for that sport. So let's say instead that I had this example, right? I could have changed this to, instead of thinking about the differences in quality for player, what if I was looking at the same quality player, but the marginal revenue per win, let's say in 2020, is greater than the marginal revenue per win in that league from 2019. And let's say we're looking at a player that's signing one-year deals for the sake to make this easy. Right? Well, if demand for the overall sport increases, we know the marginal revenue per win is also increasing. I'll draw a reminder of this in a second. So any demand increase for the overall sport is going to increase the marginal revenue per win, which, even if we hold the quality of the player constant, in 2020, those same number of additional wins that player brings in is going to be worth more to the team. Even if the marginal number of wins, right, they add, say, 2 wins, well, if those 2 wins in 2019 were worth $1 million a piece, then the team will be willing to pay that player up to $2 million. Or sorry, I said 2 wins and $1 million. Or did I say that backwards? I'll say it again. So let's say the marginal wins from that player is 2, right? And each win in 2019 is worth $1 million of additional revenue. So the team would be willing to pay them up to $2 million. If that player brings in the same number of additional wins, 2, but in 2020, each win is now worth $5 million, well, now those same 2 wins are worth $10 million to the team, right? And so the team is willing to pay that player more, right? Because the marginal revenue per win increased. So it'll be the exact same mechanism, right? Or not mechanism, sorry. The mechanism would be different, but it'd be the exact same shift, right? You would still see this increase in demand curve. It's just operating through the marginal revenue per win as opposed to kind of the quality of the player or the number of additional wins the player is bringing in. Any questions on that before I keep going? Shouldn't be too bad. So just kind of explain why that demand curve shifts. It's because that one component, the marginal revenue per win, could be changing. And we looked at, kind of already equilibrium changes. This is just like any other market we're looking at. We could compare the equilibrium before and after from those demand or those supply increases or decreases. Okay? And a lot of these examples, probably a lot more focused on demand because the things that would shift demand are things that we kind of follow the profit maximizing behavior of these teams, but also team preferences are pretty similar in terms of what they want from the player, right? They want a player so they can win more, additional games or. But when it comes to looking at supply shifts, well, we're thinking about an individual player. Every player's indifference curve is going to look different, right? They're all going to care. Some of them might care a little bit more about money. Some of them might care a little bit more about, their leisure hours might be worth more because they have a family versus, some of them are getting closer to the end of their career. So there's all these differences in players that would really make the supply shifts kind of player dependent. But all the demand shifts we can think of are not team specific necessarily, okay? So why might the number of workers kind of not change? So if we're thinking about the number of players that they're adding to teams, even if we see, the demand for, the NBA is increasing, why might not we see a higher number of equilibrium number of workers? Well, we have things like roster sizes, right? You can't have an infinite number of players on your team. And so the leagues kind of have these things set, okay? So what does a roster size really do? So if instead we take a step away from thinking about the labor market for an individual, for a single player and what wage that player is going to be paid, let's think about kind of overall that team is going to have a certain level of demand. And here we can think about the quantity of labor being if I can get this on, there we go, the number of players that team wants, okay? So I'll use, honestly, I don't know all the roster limit sizes, and I know that in Major League Baseball it's 25, so we're going to use Major League Baseball as the example, right? So here's wage. Let's say there's the demand curve for labor. Here's the supply curve. But here we're thinking about the number of players. So the idea is like the very first player I add is going to be the player who is of highest quality, right? So I'd be willing to pay them the highest wage. Next, player that I would add is the kind of the next best, and so on and so forth. So there would be some equilibrium level I could identify here. So if let's say that ends up being for that kind of last person, and maybe this is an example where if you want to make this fall a little bit more in line with reality, I wouldn't have an equilibrium wage here. It would likely be that the teams are kind of acting as like price discriminate, like they're able to kind of pay each player exactly what that player is worth to them. So they could, have not a single price, but multiple prices, not a single wage, but multiple wages for these players. But the equilibrium quantity that they arrive at is 30, right? So how can we understand roster limits? So let's say this Major League Baseball team wants 30 players, but the roster limit is set at 25. Okay. So what's that going to mean for the lower quality players that we kind of fill our roster with, right? Or the kind of lowest quality players that end up on the team. Well, it means that when we look at the actual wage data, right, if I know that this is kind of where I'm limited to, I know that that 25th player would be willing to play for that wage, right? Or supply that, kind of supply their labor for this wage level or this salary amount. So when I look at the actual data, it might look like, you know, for some of those kind of lower end players, right, I'm going to see lower wages than if I don't have any roster limits set, because now if I don't set any roster limits, I'm going to end up with kind of 30 players, and kind of the wage they're willing to work for would be a little bit higher, so I end up having to pay that. So if we look at the actual data, it's a little confusing with roster limits, because in the data, if I limit the roster at 25, we're going to see lower wages being paid on average than if we look at the roster limit, or sorry, if there were no roster limit and the team added 5 additional players, they might actually have to end up paying those players like a little bit higher amount, right? Now this is tough because we also have quality differences in those players. So I always like to think about the best way to think about roster limits is you can't continually add the highest quality players because you just don't have enough, there's not enough money out there, right? You can't add 5 of the highest quality players because you'll run out of money, right? So think of this more so as like not the overall labor market, but the labor market for kind of your backups or your reserves, or right, because not a lot of times, especially if you look at like, I don't know, NBA is a good example. There's players who just hardly play ever at all, right? So you're just thinking about for the players who you're trying to fill your roster with, this roster kind of limitation is going to lead to that. You can get kind of those who are willing to play for the lowest wages, right? You're going to select those who are willing to pay for the lowest wages. Excuse me. Whereas if you want to kind of continue to fill it out, kind of your bench players, you know, who maybe didn't want to play for this wage because, I don't know, their outside option, they could have made just as much money outside the NBA as they could in it, or the MLB as they could in it. You can actually see that the last player out of the team will actually be playing for a lower wage. But I don't want to focus too much on kind of these roster limits, but that is an idea if we're thinking about the quantity of workers. Yeah.
What if like the roster limit is 35 or above the equal agreement?
So if it's out here?
Yeah.
Yeah, so if let's say teams, so the team wishes they only had to have 30 players, right?
Yeah.
But the league maybe forces them to have 40. So, excuse me. If we think about the wage that they would have to pay, right? It's going to be somewhere up here, so I'll call this W2. What's that going to mean for the league? Well, if I'm paying all these players right here, I'm paying all of them a wage that's greater than the amount of revenue they're bringing into my team. So what's going to happen to the team here if I force a higher roster limit than what they would like? Yeah, they're overpaying for worse players, which means their profits are going down, right? It's costing them more than the amount of additional revenue they're getting back. So do leagues have roster limits ever set too high? I don't have a good answer to that. I would guess, you know, the league doesn't make decisions to hurt itself more often than not. So I'm doubting we could find a lot of examples where they had unless maybe if we went back early enough to where they just didn't have any, right? Maybe maybe if they didn't have any and then they tried, you know, maybe it was trial and error the first few years, they got it wrong. But, you know, doesn't make any sense to like force a team to have more players. You're just going to be hurting the teams. You can if you don't have any rules and they're setting on this optimal amount of 30, okay, like as a league, you'd be hands off. But yeah, if you did set it too high, you basically would just be eating into the profits of your teams. It's a good question. Any other questions before we keep moving here? All right. So you can also think about something else that's going to cause a difference in wages for players. I don't think I have anything. I think I left this blank. So let's see if we can get maybe someone can guess kind of where I'm going with this. I might run out of paper. Careful here. So quantity of labor, wages. Let's think about supply curve. So to make this easier, let's think about one individual player again, right? So the labor supply of one individual player, we have it right here. Okay? Doesn't hit the backward bending part, just to make it a little bit easier on us. We'll simplify that. Let's say we've got small and large market teams. Okay? So if we think about the demand curve for labor from a large market team and the demand curve for labor from a small market team. Okay? So this is the value of the marginal wins per labor from a large market team, value of the marginal wins per labor from a small market team. We know that's comprised of two components. Now the one component, let's assume for a second that the large and small market team will equally benefit from that player. All right, so it's not like we have, oh, well, they have a position need here, they need a center and this team needs a guard, or this team needs a quarterback, this team needs a running back. Let's assume this player adds the same number of additional wins to both teams. So there's no differences in this player joining a small or a large market teams in terms of their quality, in terms of how many wins they'll add to the team. So if we think about large and small markets, what's the other component? We have the marginal revenue per win. If I compare the marginal revenue per win of a large market team to the marginal revenue per win from a small market team, which way do you think that inequality goes? Marginal revenue per win would be, yeah, right? Greater for the same number of wins, right? Generates more revenue in a large market than a small market. Okay? So, you think about here, large market, marginal revenue per win, and small market, right? And so this is where the difference is occurring. Okay? So if the marginal revenue per win in a large market team, for a large market team is greater, that just means their demand curve is going to be greater. So if we're drawing out the demand curves, the demand curve from labor from a small market team should be less than the demand curve for labor from a large market team, which if we compare the equilibrium points, you can see that the wage, I'll move my hand in a second, from a small market team is going to be less than the equilibrium wage that a large market team would pay. Or once again, if we wanted to, we could do the idea, okay, if the amount of labor supply is fixed, I can only supply a certain number of hours, then the small market team would be willing to pay less than the large market team. And that kind of just makes sense because the same number of wins is worth more dollars, right? Because there's higher additional revenue brought in to a large market team. So they're going to be willing to pay up to that point, or a wage up to that point, so you're willing to pay a higher wage. Any questions on that? So we can start to think about, a lot of different specific examples that we see and what would explain kind of salary differences, right? So we've already talked through quality, right? Why does, LeBron James get paid more than Carson Edwards? If you don't know who Carson Edwards is, I'm a Purdue fan, the tournament's about to start, so that's why I chose him. Well, there's a huge quality difference there, right? So the wage is going to be lower. Why do I see maybe, this actually be really interesting. I haven't seen anyone break this down, but you could probably look up the mean salary, or probably the median salary is a better measure. If you look at the median salary for like New York and LA teams, I'd put a lot of money that those median salaries for the teams are probably a lot higher than the median salaries for Charlotte and Indy, or choose your other kind of smaller market towns. And that's really because you're thinking about there's a difference in that marginal revenue per win in those types of markets, right? Large versus small. Okay. I think that's all I want to say there. Kind of thinking about, we're comparing, teams, this large, small market could be driving some of the differences in wages that we see as well. Where are we at in time? Oh, okay, we're good. So I don't know how much I really want to dive into this paper, but it really relates to what we talked about today, and I don't want to start with it like next class. So there was this paper that was written where someone actually attempted to try to put some numbers to like what the value of the marginal product of different players actually was. Okay? So what they did is they first tried to just predict the kind of number of additional wins, right? So they took all this data. So every single time they had a player I on team J, they looked at the change in wins from one more point, right? I didn't put the coefficients on all these, but you can imagine if this was an actual linear regression, this was the number of points per game, I believe. And so there would be a coefficient associated with that. And the number of rebounds per game, coefficient associated with that. So they had all these coefficients that told us what's the increase in wins if a player scores one additional point per game. What's the change in the number of wins if a player scores one additional records one additional rebound per game, and all these other kind of measures. Right? Well, they then had all these coefficients, and they also had the player data. So they know how many points per game a player scored. So they basically used all these coefficients, and then for the value of the variables, they just say plugged in the number of points per game LeBron James scored, the number of rebounds per game that LeBron James had, the number of steals. So plugged all his information in, multiplied, each one of those by its coefficient that they got from the linear regression, and basically come up with the number of additional wins LeBron James brought in. But they could also do this for every single player, right? So they ran this linear regression, which could predict the number of additional wins brought in from all these different statistics. And then for each player, kind of calculated the number of additional wins they brought in based off of their own statistics, right? Their own points per game, their own rebounds per game. They then went out, and this is where it's a little bit tricky because the revenue data is, a little bit difficult. You can kind of look at revenue generated across, a 50-year time period. Each observation is how much revenue was generated that year, how many wins did the team have. But it gets a little bit hard to parse out because, there could be cascading effects, like wins from previous seasons could carry over. But assuming they did that correctly here, which if you read the actual paper, there's probably some skepticism. But they basically obtained numbers for the additional revenue that was brought in per win for every single team, right? Then matched those up to the players that were on that team. So they basically could then calculate, right? I now have both the measures, right? I have the number of additional wins that players bring in. I have the marginal revenue per win for the team that player's on. Multiply those two together, and I'll have that player's value of their marginal product of labor, or the value of their marginal wins, right, they brought in. So it was kind of interesting to paper if you look at the numbers. They then look at what that value is and what the actual salary paid to that player was. Now, there's some more complicated issues in this kind of, that the league might put on, like if there is a salary cap, potentially players take less money. So if we looked at LeBron James in 2006, was also relatively early in his career, right? He was worth $28.9 million. Like that's what we would predict his value of the marginal product of labor was. And he was only being paid $17.5 million at the time. Right? And now, this can change year to year, but in that specific year, that was the case. And then we had Tyson Chandler, I think, was the one that was actually the most underpaid because I think his value is $22 million, but he's only paid 13.6. So they were almost getting like maybe it's not be the most underpaid. He's just one of, right? Him and LeBron look like they're both about $10 million underpaid here. So it's kind of an interesting paper where they really try to use linear regression to get at these very fundamental basic concepts, which is are players being paid what the demand for their labor is, right? So what is maybe one reason why we see players being paid wages below the value of the wins that they're bringing to a team. So up to this point, I've drawn everything. We've identified equilibriums as the point where supply is equal to demand. What's a situation where the equilibrium is not where supply is equal to demand, but where the supply curve maybe is equal to the marginal revenue curve? Or the marginal expenditure curve is equal to the demand curve. Yeah, situations where we have monopoly or monopsony power, right? So the one that would explain kind of being underpaid is the monopsony power, right? That's where we said, look, if teams have some type of monopsony power, they can underpay players, right? They can give them a wage that's less than what the equilibrium would be. Okay? Now, I don't think we'll dive too deep into those topics today, but those are eventually kind of working their way in. But yeah, they also in the paper investigate other reasons, like maybe teams are just not evaluating talent correctly. So they like tried to figure out what it's not worth going into exactly the procedure they use, but they tried to figure out what teams were putting more value on, and what they found is they're putting too much value on points when you look at the wages and the kind of correlation with the statistics, the performance statistics, and that they weren't valuing things like rebounds and steals enough, right? So teams were basically really bad at predicting the number of additional wins, right? Which, this was 2006. A lot has changed since then, where like every team now has like their own kind of data, their own stats department, their own kind of numbers guys. So I'm guessing it's not near as bad now as it was in 2006. Okay, so the next thing we'll talk about, and I think I'll have enough drawn, so I don't have to redraw this, but an interesting part of labor markets, in a non-sports example, I want to increase the productivity of my worker, right? In these sports examples, what's the productivity? It's the number of additional wins, right? Or the quality of that player. So I want to increase the quality of that player if I can. So what I might do is I want to invest in that player so that they perform better in the future, become higher quality players, bring in a higher number of additional wins in the future. So I invest some money, we'll call that cost C, right, into training this player, right? So maybe this is the idea that, I have this player, I see some potential, and so I really invest a lot of my resources into improving that player's quality. Right? Actually, one you can see a lot of this as a lot of like Dominican, Cuban, not Cuban, well, yeah, some Cuban, but like a lot of the islands kind of south of Florida, a lot of MLB teams started going there and kind of taking these really young players and investing in them early and then putting them in kind of their minor league systems and trying to develop them into a higher quality player. But that came at some cost to them, right? So if I can increase the productivity of that player, the marginal productive labor, or increase the marginal wins of that labor that I've invested in, okay? So what is that essentially going to do to my demand curve? It's going to increase it, right? When we thought about the two components here, and this is, we have large and small market, but if I can increase the productivity of that player, the number of additional wins they can bring in, I've essentially invested so that that investment causes an increase in the demand curve for that player. So if there's things like free agency and this player can kind of pick and choose, well, now what happens? After I see this demand increase, well, now the equilibrium point is going to be that I'm going to have to pay that player a higher amount of money. So how much higher? Well, however much the increase was in their marginal wins per labor, right? Or the increase in the value of that change in the number of additional wins they brought in. So I will benefit, but I'm also going to have to pay that player for their improved quality as well, right? Unless I can create like really long-term contracts, right? But let's say not worst case scenario, but let's say we start out where players sign a contract every year. Let's say that was a scenario. In year one, I invest in this player, and it costs me some amount of money. Well, they get better. So then the next year when I go to sign a contract with them, not only did I have to pay to train them, they now will come to the team and say, well, I now know that I'm worth more to not just you, but all these other teams, right? And so I now demand a higher wage. So yeah, I improve the quality of the player, but I end up having to pay for it with this higher wage. So does it really make a lot of sense? No, right? Right, wages increase because I increase the quality of the player. Even if I break even, right, I still, I pay the player exactly what they're worth. Well, now, yeah, I have a higher quality player and maybe I can win a few more games, but it came at a cost, right? There was no additional revenues because the additional revenues that would have existed, I had to pay for them through that player's wage, right? Now, this is if I do one-year contracts. You can imagine we could complicate this further where, well, if I have a player for 10 years, I can make that investment early and I don't have to pay them that higher wage for another 9 years, right? If I can improve their quality while they're under this long contract, well, man, I'm not going to have to pay them a higher wage for quite a while. Okay? So I've always, you can kind of imagine, and there's different, I think, rules on this in the NFL, but it makes a lot of sense if you think you have a player that you could increase their quality by quite a bit by investing in their training. If I'm going out, I'm trying to sign young players to very long deals, right? I'm trying to sign rookies to very long deals if I think like they're guaranteed that they're going to be a good quality player, right? I am always gambling because, right, they might end up not being as good as I thought they were. But let's assume that I'm correct in my assessment of that player. I would want to invest in training that player, improving their quality as early on in a long-term contract as possible, right? Because I don't have to pay them a higher wage, right? Which I know that I will have to eventually if there's other teams that want them because I'm increasing their demand curve essentially. So I want to invest early in a long contract because that way I'll only have to pay the training cost. I won't have to pay them a higher wage until 8, 9 years down the road if I signed a really long contract. Okay. Does that make sense? Are there any questions on that? I know I don't have that in the slides or anything, but that is kind of the idea of thinking about if it wasn't year-by-year contracts, but longer contracts, I want to make the investments early. So if the player leaves the team, right, let's say that the team can't pay the higher wage and the player leaves, well, now I'm also just left with the amount of training costs. So either way, I'm left with the training costs, if we think about this as year to year. So it doesn't make a lot of sense for teams to invest too much into these players, right? Now, the one difference is I'm talking about this improvement in quality as though it's general, right? General skills or quality increases that player would be just as good on team A as they would on team B as they would on team C. However, what if they can invest in skills that aren't general but very specific to that one team? Okay. So let's say we got a player and they learn a certain type of offensive scheme in football. I don't understand X's and O's about football at all, but let's assume that you can teach, a certain type of offensive scheme to this player that no other team in the league, team in the league is using, right? So there's only this one team that this offensive scheme is being ran by, right? Well, if I teach that player, I invest into teaching them that, and I improve their quality, what's going to happen? Well, so we go here to the labor market to understand. So let's say we've got the supply curve for labor. And, if it helps, we're thinking about two different teams, right? So let's say that the player has no preferences for either team. They would supply the same amount of labor at the same wages to both teams, right? So the supply curve is the same. However, when it starts out, we had this general demand curve for labor. And we can think about this as for every other team in the league, we'll call that team B. It could just be one team, but we said no other team in the league is running this offensive scheme. So this is kind of like a representative team. Right? The demand curve for labor would be there, and the wage, the payer would be played on team B is right here. Now, before they invested, team A would have been, the value of the player of team A would have been here as well. But because they taught them this offensive scheme, we think about this equation again. They improved the quality of the player, but only if that player was running this one offensive scheme. Right? That's the skill that they gained. So we only see this increase in the demand curve if the team runs that offensive scheme, which we said the only team in this example that was running that scheme was team A. So what's going to happen? You might think, oh, well, this is perfect, right? Like I can, the equilibrium wage is increased, nothing has changed, right? The team A is still going to have to pay this player a higher amount. The problem is, if the player comes to the team and says, this is, if I go over here, that's the wage I want, right? What is team A going to do? It's going to say, well, look, I could offer you this amount right here, just barely above the wage that every other team would be willing to pay you. And I know that your outside option, there's no other outside option that's better than that. So even though you're worth a much high, in equilibrium, you're worth a much higher amount of money to that team. And if there was competition for you, your wage would go up by learning this offensive scheme. If no other team in the league is learning that offensive or running that offensive scheme, that skill brings no value to any other team if they decide to sign you. So team A has this huge advantage where they could actually offer you a wage all the way down to the wage other teams would pay you, and they know that you would be indifferent, right? So they don't have to pay these higher wages because there's no other team. This is not a general skill, it's team specific, right? Now, it's hard to teach, if you think about different sports and examples, like I kind of found a good one here, I think, but there's not a lot of cases where a skill is going to be team specific and not general, right? I don't know. If I teach you how to shoot a three-pointer, that's pretty universal to most teams, right? Or at least there's going to be at least one other team who will value that, right? But maybe, there are some examples where, if you're running different types of offenses or defenses or, I could think of, maybe if we went to like Formula One or something where you learn to drive a specific type of make and model, or not make and model, but whatever, brand, I don't know. If there was differences in like the equipment you're using on your team there in that racing sport, maybe we could see another example that would apply. But I think like learning a certain type of offense or defense really does kind of point out a good example where you could see these team-specific skills actually exist, in which case, right, there's no other team that kind of values that player. I think I did NBA here example as well. Like maybe you run a fast-paced offense, but no other team does. Then, that team made the investment. They don't ever have to pay higher wages. They can improve the quality of their player, but only to their team. And so they never have to pay those higher wages. So the value on the current team, if that player threatens to leave, they can say, okay, leave. We know they're going to get a lower wage than what, you're worth on this team. And so for the team, this general skill, right, those aren't very attractive, but team-specific skills really are. Any questions on that? Let me think. Oh, I didn't mean to hit that. My brain's not thinking. I think I want to start off with this next class because I want to go through. Yeah, we'll hold off. We'll kind of end here for today, so end a little bit early. we'll revisit some old topics. You can already kind of see like unions, and we'll go a little bit more in depth to them. We'll look at or review monopsonies and kind of continue to talk about predicted wages for players, and eventually get to some of the reasons, monopsony and monopoly power being one of them, why we might not see wages being paid as to what the player's actual value to the team is. Any questions for me before we get out of here? All right, like I said, I will be getting those exams graded throughout the rest of tonight as well as tomorrow. Hopefully I don't have any to finish up on Thursday, but if I do, maybe grading a few of them Thursday morning. So I'll have a little more information about what the performance was on the exam when we meet on Thursday. And other than that, I think it's supposed to be nice. So make sure you enjoy the weather tomorrow since we don't have class. I can tell you to do that. You know, if you want to skip your other classes, I guess I don't care as much, right? All right, we'll see you guys Thursday.